because there is an order and we should follow that order. All right,
Yeah.
so we're actually gonna start with 6.6. Is that okay?
Yeah, the thing is, I already actually did a few of these, so can we skip down to like 7, 8, and 9 in
Yes,
6.6?
of course.
Because like my friend is like a math tutor and she helped me with it earlier, but we like did
Excellent. That's great. Yes, you said 7 or 5.
7 and then like
Is
8 and 9 are like the ones
is
I didn't
is
do.
this 7? Because it's labeled as 5, but it looks like it's supposed to be 7.
No, that's not it.
All right. So
Is
unfortunately,
that
these came in a weird order where I'm struggling here to get what you want. Could you just read off the problem you want us to do next?
it's 3x squared plus 33xy plus 84y squared.
Like this?
Yes.
Okay. So first thing is just ignore the fact that there's a y. Just rewrite it without the y's. Okay, that's thing one. Thing two is that you should always look for a GCF. So is there a number or a letter that goes into everything?
No.
Does 3 go into all three of these? Could you divide each of these by 3?
Oh, yes. You
Yes.
divide 84 by 3?
So the way you test is you add the digits, and if it's a multiple of 3, then it does work. This is called the divide and slide method.
Hmm. Wow. It's interesting.
So this becomes x squared plus 11x plus 28. And I'm guessing you know how to factor this.
No, I don't. Oh wait,
Okay,
yeah.
so,
Is it
so
the
you're looking for,
where you draw an X and then like 28 and 11 on top and bottom?
you can do that. You're looking for two numbers that multiply to 28 but add to 11.
7 times 4?
Yes, that becomes x plus 4, x plus 7. Don't forget to bring the 3 down. Now, if you remember, I told you to ignore the y. Well, you have to put it back in. That's the only thing that you might forget is to put that y back in.
All right.
Now, they might teach it differently, but that's the way that I like to show it. Kind of reduce it down to something else. All right, so I do see that do see that problem now. Do you want us to go to 8 next?
Yeah, can we?
Yep.
Wait.
Question?
No.
Okay. So the GCF that you're looking for, it's either a number or it's a variable or it's both. So is there a number that goes into 8, 16, and 10?
2?
2. So you divide a 2 from each of those. So you end up getting 4x to the 5th minus 8x to the 4th minus 5x cubed. There's a 2 on the outside. And then you look to see variable. There's obviously an x in all of them. What's the smallest exponent that you see?
X to the third?
X to the third. So you're going to divide each of these by x to the third. And that's what goes on the outside. So what are we left with inside parentheses here?
4x squared minus 8x minus 5.
Okay, very good. Now this one is different than the previous ones. It's not a 1 in front. Do you remember how to do these types? It has something to do with the 4 and the minus 5.
No, I don't remember.
So you multiply the 4 and the minus 5, which gets you minus 20. And now you're looking for two numbers that multiply to minus 20 but add to negative 8.
Um, wait, let me think. Uh, I don't know. I can't.
So you have to build a list. It's like -1 and 20, 1 and -20, -2 and 10, 2 and -10, -4 and 5, 4 and -5. You have to build this full list. Do any of these work? Do any of these add to -8?
Yeah. 10
Which
minus 2.
it's 2 and minus 10. The order matters. I have to get to -8. So
Oh,
then you're splitting apart the -8x into 2x minus 10x. And then It's called factor by grouping.
Okay, hold on. Let me write that
Have
down.
you seen this before?
I mean, like, I've seen like the concept before, but I guess like the way I learned it is like a little different. But like, I
I mean,
get it.
you can use that X thing if you want. I don't show it that way, but you should do it however you like to do it. And that's what I was kind of alluding to. There's a an order to getting this all down, and we're not really doing that. We're sort of jumping around.
Um, but is this like the final answer? Like for
Nope,
X?
nope. There's a lot more to do.
Oh, okay.
Um, so what is common between the 4x squared and the 2x? What's the GCF?
2x?
2x. So you're kind of again dividing and sliding. This becomes 2x plus 1, and then you put that in parentheses here. What goes here such that when you multiply in, you get back to the previous line?
-5 or
Negative 5.
negative 5? Wait, is it right?
Yes.
Oh yeah.
Question?
Sorry, I just okay. -5. Oh wait, I remember now. And then it's
So now,
2x minus 5, right?
yeah, 2x plus 1, 2x minus 5. But then don't forget to bring down the 2x cubed like that.
Got it.
And then do you want us to do 9?
Yes, please.
Okay. All right. Uh, so we're looking for GCF again. Is there a number that goes into all three besides one?
No. No.
Nope. But they all have an X, so you can factor the X out. 20y squared plus 9y minus 20. All right, now this one's kind of horrible. You'd have to multiply these. 20 times negative 20 gives you negative 400. And
Yeah.
now you're looking for two numbers that multiply to negative 400 but add to 9. So you gotta kind of be able to do something like this, build this list, which could be very, very challenging. Um, I,
Yeah.
I don't know how you guys are doing it in class, if you're allowed to use calculators. What are you allowed to use?
We're not allowed to use calculators, but honestly, like, I don't remember doing like one this big in class. Like most of the time they were pretty easy.
Right. Well, so you'll end up finding here that one has to be positive and one has to be negative. I wrote them all as positive. So the one that does work is which one here? 16, negative 16 and 25, or 16 and negative 25. It ends up being the top one here.
Yeah.
And then what I kind of didn't really emphasize in the previous problem is that you have to choose. Is it minus 16y plus 25y, or is it 25y plus 16y? It kind of up to you. It's like, which one pairs better with the 20? Does minus 16 pair better with 20, or does 25 pair better with the 20? That's kind of up to you. What do you say?
Um,
There's
um,
not a wrong answer.
Probably, I don't know, -16.
All right, so negative 16y plus 25y minus 20. And you're again finding the GCF between those first two. What goes into both of those?
Um, 4y.
4y. And that becomes 5y minus 4, 5y minus 4. What goes out here?
Um, 5? -5? No, wait, hold on. Yeah, -5. No, wait, +5. Sorry.
Right. Yeah,
Okay.
one or the other. So then it becomes 5y minus 4, 4y plus 5. And then don't forget to bring the x down.
All right.
All right, so what else? Where should we go from here?
Um, Maybe can we go down to 6.7?
Sure. So 6.7. Of course, that's the first set of pictures you sent. All right. Yeah, so number one, these are perfect square trinomials and difference of squares.
Yeah,
Looks
I
like,
remember like specifically in class, like I did not understand these at all. So can we go really slow?
sure. Let's start with the easy ones. Number two, maybe you already know these, and then we'll go to the harder ones, the perfect square trinomials. So this is called difference of squares.
All right.
And so the game here is you're trying to figure out what is it squared minus what is it squared that gets you back to the previous line. Like what number do you square to get to 121?
11.
11. And what do you square to get to y squared?
Why?
Good. So this is what I call A, and so there's this reference that you need to know. You need to know that A squared minus B squared becomes A minus B, A plus B.
Oh, all right.
Okay. So now that you identified A and B, you're just putting them into this formula. Y minus 11, Y plus 11.
Got it. All right.
So why don't you try number 6 here? I'll leave this up. Really
Um,
similar.
got it. Is it y minus 6 and y plus 6?
Yeah. Multiplied together, or you share that multiplied together. All right, good. Now we're going to go to 14. And this one is also difference of squares. So one of the things that you're going to do later on is you're going to have to identify which one it is so you know how to factor it. The thing you're looking for here is that there's two terms and they're separated by a subtraction. The game is still the same. Like what squared gets you back to 25y squared? What squared gets you back to 36? 36, you know, is 6. To get to 25, you need a 5. To get the y squared, you need a y. So
Mm-hmm.
your A is 5y, your B is 6. So once you identify those, you know what goes in parentheses here. What would go in parentheses? What's the A minus B, A plus B here?
5y minus 6, 5y plus 6.
Very good. So if you understood that, let's have you try 15 on your own. And it's pretty much the same, just different numbers.
All right. All right. I got 9y minus 10 and 9y plus 10.
Very good. So that's everything for difference of squares. You occasionally get problems where there's a GCF to consider, but that is not the case here. All right, so we're gonna go look at number 3 first. So the rest of these, I don't know why they're grouped together. I don't really agree with it, but they're called perfect square trinomials. Does that name sound familiar to you?
Yeah, a little bit.
Okay. Name's not important, but so they have this form. A squared plus 2ab plus b squared. So it's kind of like the last one. You got to figure out like what it is that you're squaring. Get back to that. So like the number's the easiest. What's the square root of 144?
12.
Did you say 12? I'm sorry.
Yeah, 12.
12. Okay. So B is 12 and A is that. Does that make sense?
Uh-huh.
Okay. So then the test, you have to test this. Like it's not a guarantee, but you multiply A and B together and then you double it. And do you get the middle term?
Yes.
Okay. So when it's in this form, like once you verify that it's in this form, it becomes A plus B squared like that. So your A is X, your B is 12. This thing becomes X plus 12 in parentheses squared.
Mm. How do you know when to do that versus when to do like some of the other ones we were doing earlier, like with the plus and the minus?
Well, there's some overlap. Like you could do two numbers that multiply to 100, but add to 20.
Um,
And that still works. You just find that they're the same numbers.
um, all right.
But this is another perfect square trinomial. So like the shortcut here is you take the square root of the first and the square root of the second. That's x, and that's 10. You double it, and does that equal the middle?
Yes.
It does. So this has the form that we're looking for. It has the form of a squared plus 2, ab plus b squared, and this becomes a plus b squared.
All right. So the answer to this one would be x times 10 squared.
X plus 10 squared.
Got it.
Okay, now they're not all. Why is there duplication? Your teacher duplicated some of these.
Oh, sorry.
Uh, well, it doesn't. Yeah, it's like maybe there are. We're 7, 8. They're there. No. Oh boy, you got some other ones here too.
Oh, sorry.
Those are much worse. All right, let's go back to number one. Okay, so what's the square root of 64x squared?
Um, 8x,
8x. And what's the square root of 25?
5.
5. So when you multiply these together, you get 40x. And when you double it, you get 80x. And you might say, well, that's not the same. And I would say, you're right. It is not the same. This is the other form. A squared minus 2ab plus b squared equals a minus b squared. So it's a lot like the previous one. It's just that it's a minus b instead of a plus b.
Got it. All right.
So what would this one become? What goes in parentheses here?
Um,
What's the
8x minus 5 squared.
good? Fantastic. All right. So now let's look at one like 5. And it's got kind of the like it looks like a perfect square trinomial, but you always look for a GCF first on your test or your quiz. Like that's what you need to look for. Because if you don't, you make the problems a lot harder than they need to be.
Got it.
So is there a number or a letter that goes into all three?
3.
3. So this becomes 25x squared minus 10xy plus y squared. And do you remember what I mentioned doing when there was two letters?
Like pretend the y isn't there.
Yeah, now you do have to remember that there's really a 1 there. So it's 25x squared minus 10x plus 1.
All right.
Now, is this a perfect square trinomial? What's the square root of 25x squared?
5x,
And what's the square root of 1?
1.
And if we multiply those together, that's 5x. And then if you double it, do you get this right here?
Um, no.
What's wrong with it?
It's like positive and it needs to be negative.
That's okay. So it's going to be the a minus b squared this time.
Oh, all right.
All right. So it becomes what? What's the new?
Um, 5x minus 1 squared.
Okay. And that's where you have to somehow remember, and this is the hardest part when you take something away like that, you have to remember to put the y back in.
Oh, all right.
You probably will forget. I mean, I hate being negative, but like I sometimes forget. And but it's easier than trying to like figure out what do I do with it. You just wait till the end to put it back in.
Alright, I'll try to remember it.
Yeah, it's easy to forget. But that GCF thing, really, really important. Always look for greatest common factor. It will make things considerably easier.
Is there ever a problem where there isn't one?
GCF.
Yeah, like, it's like, and do you think I'll ever get a problem where there's like no GCF or probably not?
Yeah, I mean, a lot of them don't, but like you want to look for it first because it makes things so much easier.
All right.
All right, so this right here is called difference of cubes, and it has a known formula. It's x minus y, x squared plus xy plus y squared. Check with your instructor and see if you need to remember this for the test or the quiz.
All right.
You know, you may get a garbage answer like, well, you need to know everything. I mean, just press them on it. Because it's just one more thing. Now, there's also what's called sum of cubes. And the only difference is that it's a sum. Now I'm writing the formulas underneath so that you can see how similar they are. The
Mhm.
difference is in the first term, first binomial, and then here in the next one, it's opposite in sign. So you might remember like, okay, if it's minus, this is a minus and these are pluses. If it's a plus, this is a plus and this is a minus. I'll leave that up to you to decide. Um,
All
but
right.
you need that for like a problem like uh 9 and 15,
All right.
which I mean I don't know what they're out of order. So we'll do 9 here. They're not hard if you have the formula. Okay, but yeah, you gotta know the formula. So this is x cubed plus 7 cubed. So your x is really x. X is the thing that you're cubing, and then y is really 7.
All right.
So this becomes, sorry, I don't know why I didn't put an equal sign there.
Mm-hmm.
Ooh, x plus 7, x squared minus x times 7 plus 7 squared, like that. And then you should simplify. Like you should say, okay, let me not multiply, but like, okay, numbers come before letters, and 7 squared is 49. That would be good to do.
Got it.
Okay, so we're going to look at 15 together here before we move on to some other types of factoring.
Right.
All right, so game plan here is you got to figure out what is it that you're cubing plus what is it that you're cubing. Like what gets you back to 125x cubed? What gets you back to 8y cubed? Like what goes in parentheses?
I know 8 is 2 and 25, I don't know.
Okay, it's 5. They don't get too large, so you might just remember a few of these like 4 cubed is 64, 3 cubed is 27. There's another question. How high up do I need to remember? That way you know. No mystery.
Um,
But what else? Like I can't just leave. It's not just a 5. How do you get back to 125x cubed?
5x
5x, and how about the other one?
and 2y.
Yeah, so this is where I really prefer this notation, because it's more representative. Like A is whatever's in parentheses, B is whatever's in parentheses. So what is A in this problem?
5x.
5x plus 2y. And then you're squaring the whole thing. So it's really 5x in parentheses squared, 5x 2y plus 2y squared, like that. And then, yes, you should simplify, if you're wondering.
All right.
25x squared minus 10xy plus 4y squared. Okay, I feel like that is everything for 6.7.
All
Might
right.
have even done all of them. Are there any there that you don't, that you see that we didn't do that we should do?
Not really, no. Like I think we hit everything.
Okay, so what else? Are there some other problems on here that you see that you want us to do?
Maybe
Uh,
maybe like 6.8.
6.8. Okay. So I don't see a header for 6.8. Could you give me a problem there? Is it like
Um,
number five? Then
may
no.
maybe do you see one like for number five, it says like 10x squared plus 22x minus 24 equals 0. Like they all say like equals 0 after them.
Okay, so these are just these are good to do. All you're doing is you're adding this extra step of solving after you factor. The instructions will say something like to solve by factoring. Okay,
Yeah.
what's the very first type of factoring you should always try?
GCF,
Okay, so is there a number that goes into 10, 22, and 24?
2.
So this becomes 5x squared plus 11x minus 12 equals 0. Since there's not a 1 in front, you multiply the 5 times the negative 12, that's negative 60. You're looking for two numbers that multiply to negative 60, but add to 11. They have to multiply to this, but add to this. Take a
15,
moment or two. Yeah,
4.
15 and 4. Which one's positive? Which one's negative?
15 is positive, 4 is negative.
All right. So now which pair is better with the 5x squared? Minus 4x or 15x?
Um, minus 4x.
Okay.
Wait, is there like a way that you have to divide like the 15 and the 4 by like one of the numbers in the parentheses?
No, you're just splitting apart the middle term.
Oh, all right.
And then you're figuring out what's common in the first two.
All right.
So what do you factor out of the first two?
X.
So it becomes 5x minus 4, 5x minus 4. What goes in here such that when you multiply and you get back to the previous line?
3.
Plus 3. So now this becomes 5x minus 4 times x plus 3. Bring the 2 down. All right, so now that's the factoring part. Okay, the solve part's the extra step. So you set each factor, and factors have x's in them, must have an x equal to 0. So you set 5x minus 4 equal to 0 and x plus 3 equal to 0.
What about the 2?
The 2 does not have an x, must have an x. Does the 2 have an
Oh,
x?
it doesn't like apply in?
It's not a it's not a factor. It's just a coefficient. I mean, you could divide it out and it would be gone.
Oh, all right.
So you have to be able to solve each of these. Could you solve those for us, please?
Yeah. I got X is equal to negative 3 and 4/5.
Okay, good. So like number 10 is already factored. Let's look at that one real quick. We probably should have started with that.
Mm-hmm.
Um, so it's already in factored form. The 5x is a factor and the 9x minus 10 is a factor. So you set them each equal to 0. So x equals and x equals, could you solve these for us, please?
Mm-hmm. I got X is equal to 0 and 10/9.
That is correct. All right, so let's go look at 8 8 is kind of like the one we just did now, 10, but you have to do the factoring first. So I'll keep reiterating this because it's really important. What is the first type of factoring that you should always do?
GCF.
UCF. So it's either a number or a variable, or it's both. Is there a number that goes in both 12 and 14?
Um, 6. Oh,
6
2.
does not go into 14. So it becomes 6x squared plus 7x. Is there a variable that goes into both?
X.
So you choose the lowest exponent. When you divide each of these by x, what goes in parentheses?
6x plus 7.
Okay, now you set the x terms, x factors equal to 0. So you set 2x equal to 0, 6x plus 7 equal to 0. You solve those for us, please.
Yeah. I got -7/6 and 0.
Okay, so number 9 is the next one to look at. It's a disguised problem like the ones we've been doing. You want to move to one side, and you typically move from the to the side with the um, you want the highest power to be positive.
Right.
That's really important. If you go the other way, it worked. This just could get awkward. So what is the GCF? What is the number or the letter that goes into both of these?
T.
T for sure. Is there a number that goes into both?
Um, Let me think. Like 2 maybe?
63 is odd, so 2 won't work.
Um, I don't know.
Are you given a calculator? Sorry if I've asked, but
No, not on the tests.
okay. It really will help to brush up on a few of these because it makes this so much easier. It's 4t squared minus 9 equals 0. Now you might think you're done here, but inside parentheses is another type of factoring. We did it earlier today. Do you remember what kind this is?
Um, I can't
Do
remember the name.
That's okay. Do you remember what to do?
Oh, like the the perfect square thing.
It's the one we did before that,
Um,
which doesn't really matter, but it's two terms.
like
It's
plus
difference of squares.
plus
It's
and
something.
minus.
Let's go back and look. See if we can find one real quick. Okay, so it's like this one. What
Mm,
did you do here?
like like took the square roots and then like made the signs opposite in the different problems.
Okay, that works. All right, so tell me what goes in parentheses here.
So it's t minus 3 and t plus 3. I
What
mean, wait,
about
no,
this?
I don't think 2. 2t.
Yeah, 2t minus 3, 2t plus 3. Now you have to set each of these equal to 0. So give me your final answers here.
All right, give me 1 second. I got -3/2, 0, and 3/2.
All right, good. Very good. Number 11 is the next one I see.
Mm-hmm.
If you don't like the variable, you can always change it. It's a dummy variable, so it can be whatever you want. Is there a GCF? Is there a number that goes into all three of these?
No.
Nope. So this is the worst type. This is the grouping type. You have to take that 3 and multiply it by the last.
Mm,
Now you're looking for two numbers that multiply to -48, but add to -2.
mm, hmm.
So they're two apart. The numbers have to be two apart, even though it's a negative. There's that might help.
Um, I don't know. I'm trying to think of like a list. Oh, 6 and 8,
The
and
the
then eight.
proper way to the proper way to do this is to go in order until you exhaust all of them, because you'll eventually wrap around to the other side.
All right.
So is it what are you gonna put in front? Are you gonna put is it
-6 and +8.
that adds to 2. We want to get to -2.
Oh, and then 8 minus 6.
That still is 2.
Um, 6 minus 8.
Yeah, now which one are you gonna put first? You're gonna put 6y and then -8y, or -8y and 6y? Which pairs better with the 3y squared?
Probably the -8.
Okay. Okay, what's the GCF on these two? This is the grouping part.
Why?
Okay, so it's 3y minus 8, 3y minus 8. So whatever's in parentheses, you immediately write over here. What goes in the middle?
2.
Plus 2. So this becomes y plus 2. 3y minus 8 equals 0. Now what? What's the next step?
Make them both equal to 0.
There you go. So give me your final y values, please.
All right. Y is equal to 2 and 8 over 3. -2 and 8 over 3.
Very good. Okay, that might be all the problems.
Yeah, I think it
And
might.
if it's not, let me know. I don't think we did all of them, but if you see one that you want us to do, you could just read it out loud, or if you need me to find some more,
All
do
right.
that
I don't know if this one made it into the email, but it's x cubed plus x squared equals 6x.
like this.
Yes.
Okay. So you want to get on one side.
Mm-hmm.
So you should move the 6x to the left. And then you've heard me ask this over and over, but this is how you have to think through it. What's the first type of factoring you should always do?
GCF.
GCF. Is there a GCF here? Yes, there is. What
X.
is it? It's X. So tell me what goes in parentheses here.
X squared plus x minus 6 is equal to 0.
So you're looking for two numbers that multiply to -6, but add to, what is the coefficient in front of X here?
1.
1. If you need to, you can write it just to help remind you.
All right. It's 3 and -2.
All right, you're going to set each of these equal to 0.
All right. Is it -3 and 2?
Yep, and 0.
Oh, and 0.
Yeah, don't forget about that one.
Got it.
So there's this fundamental theorem of algebra. Did you guys talk about that at all?
No.
Okay, I'll save that for another time then.
All right.
It's not that eye-opening. It's sort of depressing. Um, what else? What else do you got?
Let me see. I think we did cover pretty much everything. Just give me 1 second. Um,
I don't think we did this one, but it's up to you if you want us to do it or not.
oh, I actually did that one already on my.
Great. Excellent.
But can we do one that goes like, I know we already did one like this, but it's 64x squared minus 80x plus 25, but it's like not equal to 0. It's like just that. So it's factoring, I think.
Yeah, that's the perfect square. Do you want to do more perfect square trinomials?
Yeah, because I just like need a lot of practice.
All right, I'm just pulling up some problems here, and I'll be right with you
Right.
once I get some good ones up.
Hmm?
All right, here is. All right, so here is one for you to try. The process is you take the square root of the first, the square root of the last, multiply them together, double it. Does it equal the middle term?
Wait, is this one that I have or one that you found?
I found this one.
Oh, all right. Didn't
Do,
know if
do
I
you
should.
want us to do this one? I mean, we already did it, I think.
Oh, we did?
Yeah, we can do it again.
Oh,
Do you want do you want us to do this one?
no, it's okay. I
It
didn't
doesn't
really
matter.
think
Okay,
I did it.
so you're taking the square root of the first, the square root of the last, multiplying the results together.
Wait, let me try. Wait, so it's like 2b plus 3.
Times 3. You multiply them together,
All right.
and
And
then you double it.
yeah,
Is that the middle one?
yes.
This becomes a plus b squared. Now, a represents this first thing, b represents the second thing.
All right.
So
And
what would we end up writing here?
um mm, I can't really remember.
It's right here in the middle. What's
Oh,
a? What's b?
2b times 3.
Plus 3. Yeah, let's try a little more standard one. 16x squared minus 24x plus 9. So you gotta take the square root of the first and the square root of the last.
Mm-hmm. So 4x times 3 and then doubled and then 12x times 2, 24. So yes, it's gonna be like minus.
That's
So
right.
it's 4x minus 3.
All right, well done. All right, now sometimes let's do one more. Here's one more. Okay, give this one a try on your own, please.
Right? All right, I got 3k plus 1 squared.
You are correct. Now
Yeah.
sometimes they're disguised. That's what I was about to say here. And that's why it's so important that you're always remembering GCF, GCF, GCF. This one has a GCF,
Mm,
and I'll tell you what the GCF is because I don't want you to. This becomes 25x squared minus 40x plus 16, and now it is a perfect square trinomial.
all right, so then it would be 5x times 4 and then doubled. Wait, that's,
Oh, you're okay. Sorry, I'm jumping ahead.
oh my bad.
Yes, yeah, doubled.
20x and then doubled is 40x. So it is that 5x minus 4 squared.
Very good. So yeah. One here. Let's have you try one more here. This isn't
Okay.
super long. Okay.
All right. Let's go. Okay.
See,
Okay. Is it 2x minus 2 squared?
nope, you got to factor out the 4 first.
Oh, you do?
Got to do the GCF. Well, that's not. Yes, but this is not fully factored.
Oh, because you can divide it again?
Yeah, it's really 2 times x minus 1 squared gets you 4x minus 1 squared.
Oh, I see.
I mean, it's correct, but it's like not preferred. Uh,
I understand.
you did well seeing that though, because it's not wrong. It's just that you really should look for the GCF first.
Oh, my bad.
All right, no, you did great.